Oh, hello everyone. In previous videos, we have seen what is artificial intelligence and machine learning, how can we use it in civil engineering applications. Followed by that, in second video, we have seen its ethical considerations in civil engineering and how is it safe and all. Now, in this video, we will learn about, we will talk about AI in civil engineering. We'll show the practical case studies of utilization of artificial intelligence in civil engineering. Okay, so the integration of artificial intelligence itself in civil engineering is a rapidly transforming process throughout the world, not only civil engineering, but irrespective of any domain. It is the fastest growing skill due to its unprecedented efficiency, accuracy, and innovation. So, and from automating this tedious tasks and complex designs can be obtained, which will revolutionize our method of building and maintaining an infrastructure. So, throughout this presentation, we will explore the real world applications in civil engineering of artificial intelligence, which we were talking from the first video. So let's begin. First one is challenges in civil engineering. The primary challenges again: data complexity, resource constraints, safety concerns, and regulatory constraints. Data complexity itself is it depends on type of data which we require. It can be geospatial data, it can be environmental data, it can be any design data. Depending on that, the data complexity varies, and the constraint is it tight deadlines and limited budgets. Shortage of skilled labor is always a problem in civil engineering field. So we need an new approach or a technology to tackle this problem. Third is of a safety concern. Safeties of workers is currently a biggest challenge of us, irrespective of the construction level. The safety is becoming a concern with a lot of electrical equipment, lot of mechanical equipment, lot of moving parts. It is always the threats have increased. Followed by this, okay. Next potential applications is that we can use artificial intelligence in structural design, construction automation, and infrastructure maintenance. Let's see that. So the primary one is structural design. Initially the data which we will be fed is basically the plans of different buildings or different structures which we have constructed over time. That kind of data will be fed into the AI training model during training, and then analysis will be done on that part. And finally is design optimization. So after you feed your design into it, it will tell you where the changes needs to be done, and so that the design is optimized, reducing the material usage, minimizing the cost, and increasing the overall efficiency. Second one is automation. We have already talked about this in the first video, but in this we talk about site preparation. So site preparation, when we talk about site preparation, it involves multiple things such as excavation, grading of the aggregates, and clearing the site. So this can be automated by robots. Remote controlled robots can be utilized to do this task. And then concrete pouring, this can also be done mainly to pillars. Sometimes what happens in our domain is that when concrete pouring happens, if the pouring is improper or efficient vibrations are not given, the concrete will not set and results in air voids. So with increase in air voids, the strength of the structure will definitely be reduced. So to tackle that, we need to do this. So concrete pouring with with precision and enough quantity, we can reduce it. And welding and assembly, you know what it is. Okay, so the in this we have it. In this I made a table so which explains this traditional approach and AI powered approach. Traditional approach includes everything blah 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 done by humans, and then here it is the drone based and inspections, AI image analysis, data analysis for early defect exploitation. Next, predictive maintenance or AI driven maintenance, that, all these. And we have ethical considerations which is again data privacy. AI systems, they require they definitely require large data sets, which includes data privacy and security concerns. Thus, we have been talking. We will still talk because ensuring responsible data and responsible, evident right data which has to be given to the model should be very, very important, and it is a matter of paramount. So we need to make sure that the data given is proper. Also, privacy should be maintained. And second was one is algorithmic bias. So no bias should exist. This algorithmic bias should not exist at any cost, irrespective of whatever it is. So when we talk about algorithmic bias, we can use AI in automating the tender process. So in that case, we can't have any kind of bias to it while allocating the tender. So in that case, this algorithmic bias comes into picture. Next is transparency and explainability. Since most of our clients or the managers or the people who pays us money, they won't most of them will not have the basic idea of how artificial intelligence can actually be added in civil engineering and whether is it safe or not. So the model, despite of it being complex, it should be highly transparent and explainable so that even a layman can easily understand what it is and work with it efficiently. And then this human overview, human oversight and control, is that AI model should not be allowed to make decisions that does not require significant consequences. Which means, like, say the thickness of the slabs, which has to be designed by humans, we can design it, but for a second approach, we can take AI's uh, decision or advice. But still, we should be the uh, we should again finally be the person who will approve this. AI is a tool. AI is not a complete functionable material. AI is just a tool which helps us increase our productivity. Okay, so we should see it in that way. And then finally, okay, lessons learned is that focus data quality has to. Okay, that's what we discussed. Focus on data quality. Ensuring quality and accurate training of data is pretty much essential. And then is collaboration with domain experts. We will definitely do it. Embrace continuous learning. AI system has to be continuously updated. Prioritizing explainability and transparency. This has to happen. Finally, so when you talk about in conclusion, integration of AI itself integration of AI in civil engineering itself is a transforming industry. Still, the transformation or the shift from traditional construction method to AI powered construction method requires a lot of efficiency, lot of innovation, and again, it should be highly sustainable in that material. So, by addressing these challenges and ethical considerations, we can actually harness the power of AI to create safer, more resilient, and sustainable infrastructure model for future generations. So by the end of okay, we end this here by discussing this. Again, the last point to add up is that the shift which is happening from traditional construction method to AI construction method requires high level of precious efficiency, high level of efficiency, and most importantly, it should be trusted by people so that we don't I mean they should trust that AI can do this so that this can happen.